Alrighty, now, you guys don't have the sheet yet, do you? Okay, so many of you probably thought when you got to grade 11 physics, you'd be doing a whole bunch of word problems with formulas. And we haven't really done a whole lot of that yet, have we? We're going to put that to rest today. Okay? So yes, let me do a few sample questions with you. I think I have 5. Is that correct? Yes, 5 of them. They range from incredibly easy to a little bit more challenging. Okay? So let's take a minute or so and let's have a read here. Let me get my notes out so that I make sure that I've done these right. Peyton, you need to come grab one of these. Okay, so question number 1 says, an object starts at a position of minus 6 meters and ends up at a position of plus 10. Calculate its displacement during the trip. I think you already have one of those pages. You should look at it more closely. So the displacement is final position minus initial position. And I'm going to stress over and over and over until you get sick of me that I want you to write the formula. Okay, writing the formula is a way of you showing me I understand what I'm doing. If you make a boo-boo somehow, an arithmetic boo-boo, then I can still justify giving you some credit because clearly they know what formula to use, they can substitute correctly, they just didn't do the math very well. Okay, so please, I'm begging you, write the formula down. Okay? Right underneath that, I want you to substitute. And Anderson's smiling at me because he was planning all along to never write the formula down. Weren't you, Anderson?
Just usually don't.
Yes. Want to step into my office and we'll have a little discussion. Write the formula, Anderson. What's the final position? 10. What's the initial position here, Hannah?
Initial position, -6.
Correct.
Yeah.
Have I done that correctly?
No.
Why not? Because I haven't done subtraction, and I've sort of done, right? Here's a great example of where I know exactly what you've done wrong because you wrote the formula and showed your work. And he stares at Anderson for effect. If all you write is 4, well, there's a pretty good chance that I can figure out exactly what you've done wrong. However, as the formulas get more and more complicated, I'm not going to be able to figure that out. Okay? So I need more than a 4. Yeah, exactly. So this is going to be subtract -6, which of course is plus 16. And you should actually put meters. Meters was given in the question. You should include it as part of your answer. It's important. Okay? The units are important. Notice how the equal signs sort of line up. There's 3 steps. I'm modeling for you what I expect to see. Okay, you're missing out on the good stuff. An object moves from a position of plus 10 to a position of minus 13 in 7 seconds. Find the displacement and the average velocity during the trip. Now I'm going to start you off with baby steps here. I'm going to ask you to find the displacement and then the average velocity, but generally, as you go on, I'm going to expect you to know you need to find the displacement first before you get average velocity. Okay, so D equals xf minus xi. Final position here is minus 13. I subtract 10, and I get a displacement of minus 23. It would be nice to have units there. I'm not a big stickler about units sort of in what I call the intermediate steps, because you're going to turn around right away and you're going to fire it into another one. But it's probably a good idea for me to show you that. So everybody's with me at minus 23 meters? Then I'm going to put right beside it, average velocity equals distance over time. Displacement over time. What's the displacement? We just figured it out, minus 23. My time was 7 seconds. Do the division. I get 3.3 meters per second. Am I right or am I wrong? I did say that. So should the minus carry through? Absolutely. Would I deduct if you get that wrong? Absolutely. Legal disclaimer, I have it wrong on my sheet here. Fortunately, I spotted it. Good so far? How much would you expect a question like that worth?
4 marks.
Probably 2. Yeah, probably 2. I mean, really, folks, yeah. 1 mark there, 1 mark there. Okay? Not hard stuff. Well, I would deduct probably, if you did everything right, but you didn't write formulas, I might give you 1.5, because you haven't shown the work, and I gotta train you to do that. Think of it as you're writing a book. You can't just leave parts out, right? I'm not caring about the answer. I'm caring about, do you understand the process? It all goes up to the poster up there, right? You're not just getting it with the answer. Answer's not good enough. Okay. Number 3. Find the time required to travel 150 kilometers at a rate of 80 kilometers per hour. Which formula should I use here? I'm asked to find time, and this is something that I recommend that maybe some of you do if you're having issues, Joey. Find the time required, so that's my t. The 150 is my distance, and my 80 kilometers an hour is my velocity. What formula do you know that has t, v, and d in it? Exactly. V bar is equal to d over t. We're looking for time. My velocity is 80. Notice how I plug the 80 directly underneath the v, because it's replacing it. The time is what we're trying to find. The 150 is my d all over t. Notice again how it looks. Solve by switching the 80 and the t. 150 over 80. 1.9 hours. It doesn't come right out and say it. It just says find the time required. Would that be a good enough solution for it? Likely yes. What would you do if the question said, what would you do if the question said find the time required in minutes? You'd have to convert that, right? It would be 1.9 times 60. And I actually have 1.875 times 60. I get 112.5 minutes. Should you round that 1.9 off, seeing as it was 1.875 exactly? I wouldn't. I would leave it as 1.875 and multiply by 60 to get a more precise answer. But again, showing me your work, showing me your level of understanding is what I'm looking for. On a scale of 1 to 10, with 10 being crazy super hard, I'll never ever be able to do that. 1 being I could have done that before I came in the door today. Where would you put a question like this at? You could have done that question earlier today? I would think so. I shouldn't see any 1s, right? I don't expect any 10s because you can all do this, right? I'm thinking that you can probably put this around about a 5. 3? Well, I'm afraid you're going to see a hard one next. Here's one that's going to take a little bit more study. Let's have a look. A ball rolls down a hill with uniform acceleration. What does that mean? Means the acceleration remains the same throughout. The acceleration remains the same throughout. It starts from rest. What does that mean? The what zero? The initial velocity is 0, isn't it? The initial velocity is 0. It doesn't come out and say that. It just says that it starts from rest. And it rolls 28 meters. That is my d in 4 seconds. My time is 4 seconds. We are to find the average velocity, the final velocity, and the acceleration. Average velocity is what? We're asked to find v bar. What's the formula for v bar? Yeah, delta d over delta t, right? How far does it change position? It changes position by 28 meters. That all happens over 4 seconds. Please don't reach for a calculator. 7 meters per second. 7 meters per second. Part B. I like it when people label the parts. It means I know which part goes with which answer. It's not a hard thing to do. Final velocity. Is the final velocity 7? Joey's shaking his head vigorously. Why not, Joey?
That is the average.
Ah, very good. The average is the one in the middle. Now, times it by what? Yeah, you're right. Times it by 2. But that only works when the... no, that only works when the initial is 0. Why is that? Let's look at the formula. When you find the average of two things, how do you do it? Thing 1 plus thing 2 and divide by 2. So, in other words, are you telling me that V bar is the initial plus the final divided by 2? Is the average velocity equal to the initial velocity plus the final velocity divided by 2? Yes, Mr. Bennett, that's what we're saying to you. Average velocity is, you add them together and divide by 2, right? That's all you do. What is the initial velocity? 0. What is the final velocity? Well, that's what we're trying to find out. What's the average velocity? 7. How do you solve such a complex equation? I use finger quotes with the word complex, because it's not. The 0 really isn't there. 0 plus something is still the something, right? How do I get rid of divide by 2? Multiply both sides by 2, and what do I get? 14 equals VF. Am I going to be okay with 14 meters per second equals VF instead of VF equals 14 meters per second? Yeah, I'm good. Does that make sense? Notice that that multiplied by 2 thing that Dana pointed out correctly at the start is only going to work if what? The initial velocity is 0. Because if it's not 0, then it's not just going to disappear. You're going to have like 3 in there, right? You'd have to multiply by 2 and then do what? It'd be 3 plus VF. So to get rid of that, you'd have to subtract 3, wouldn't you? All right, now, here is where, if you haven't been paying attention, it's now time for you to do so, because this is the #1 grade 11 physics mistake. This is the one thing that caused me to lose all my beautiful hair. Got your attention now, didn't I? Acceleration is A equals delta V over delta T. Please do not write it down yet. Do I have the acceleration? No. Do I have the delta T? It is equal to 4. Do I have the delta V?
Yes.
What is the value of delta V? You'll notice that you have a 7 for V and you have a 14 for a V. You also have, you should also note that you have a 0 for V. So which V is it? He pauses for dramatic effect, and then he's going to ask a multiple choice question. Now be brave, folks. Who thinks it's 0? Hands up. Who thinks it's 7? Hands up. Couple? 2 or 3? Who thinks it's 14? Hands up. Has your neighbor not put his or her hand up? Shake your finger at them because they weasel out. It's got to be one of them. The correct answer, my friends, is none of those.
Well, you didn't have a multiple choice. That's
Yeah, it was kind of a trick
Is
question.
there a D now though above?
No, it's kind of a trick question. Now, having said that, the correct value is 14. But it's not just because the VF is 14, and it's certainly not because the V bar is 7, and it's not because the VI is equal to 0. It's because of all three of them. Please write this down. Please write that delta V is not equal to V bar, because you will not believe how many times I've had to explain this to kids, that the change in the velocity is not equal to the average. Allow me to demonstrate. You don't need to write any of this down, just watch. Let's talk about test marks. Let's say you got, heaven forbid, you got a 50 on a mark. I'll say M1 is 50. M2 is, I'll say you got 70 on your next test. Better. What is delta M and what is M bar? What is your average between 50 and 70? 60, right?
20.
Jake's using a calculator to figure it out.
Yes.
Is that your mom? Really? Do I need to phone mom and say, Mom, don't text Jake at 154 because he's in physics class? M bar is equal to 60. Does everybody got that? This is super important, Jake. You really need to focus. What is delta M? How much did the marks change by? 20. I think you will all agree that you can get that. It's not hard. How much did the marks go up by? 50 to 70 is a change of 20. The average is 50 and 70 divided by 2. It's 60. Most kids can get that. But for whatever silly, crazy, stupid reason, they want to take 7 and they want to plug it in here. Usually because Mr. Bennett is a trickster and doesn't ask that question. And because they get lazy and they don't write formulas. If there was like thunderous, ominous music in the background, I would play it right now. Dun, dun, dun. Okay, because they see, oh, V is 7, I'm going to plug it in there. They don't write delta V, they just write V, and they get it wrong, and then they get this written on their test. Then I shake my finger of shame at you. Okay, so, having said all that, you should write delta V equals VF minus VI. The final velocity is 14. The initial velocity is 0, which means my delta V is 14. Now you might say, Mr. Bennett, that's an awful lot of work to show that 14 minus 0 is 14. I think I get that. I'm not going to disagree with that. I'm not going to get too excited about you showing this, provided that the initial velocity is 0. Okay? However, if the initial velocity is 0, what happens? Things change a whole lot, so you better be able to do it. It might not be a terrible idea to do what? Write this down for the first little while to make sure you're doing it right. Because clearly it says delta V is equal to 14, and now I can take that 14 and plug it into A equals delta V over delta T. 14 over 4. 14 divided by 2 is 7, divided by another 2 is 3.5 meters per second squared. Okay? How much do you think I would give you if you used the 7 in here instead of the 14?
Nothing. Half mark.
I would deduct 1 because you didn't do this step. Okay? You didn't do step B. There's a very good chance I might just say, find the acceleration. I might not even do A and B. I'm just showing it here to show you the steps. But part of you being knowledgeable about physics is knowing what steps to follow. Okay? Super important question. Make sure you go through it on your own. Make sure you understand. If not, come see me. Who wants to try one on their own?
Me.
I do. How about you try this? How much space have you got?
You got a half page.
You got a half a page for this? Okay. Draw a line down the middle. Draw a line, a vertical line down the middle of that last little space there, and try to figure out A on the left-hand side, and then I'll show you the answer. If you get it wrong, you'll have space to write the correct answer. Jason Allard says 3.7.
Yes, I do.
An object that has an initial velocity of 1 reaches a final velocity of 12 3 seconds later. Find the acceleration of the body during that time. Right away, you write A equals delta V over delta T, and then you should realize, oh, I got to do something before that. It's always a good idea, Jake. See, this is the part where you listen. It's always a good idea to sort of think ahead a little bit before you just jot stuff down quickly. To find the acceleration, you should say to yourself, oh yes, I'm going to need delta V over delta T. Do I have those? Do I have the delta T?
No.
Yeah, it's 3 seconds. Do I have the delta V?
No.
Well, it's 11, but I don't have it, do I? Like I know it, I can do that subtraction in my head. But I need to show it. I need to show it. I need to write delta V equals VF minus VI, and I should really show 12 minus 1 is equal to 11. You should show that. But then you would write A equals delta V over delta T. Please use your pencil, your eraser, if you made a little boo-boo like that. Don't just scribble it out or draw a big arrow and I'm supposed to suddenly start read from right to left. Do it right. 11 over 3. Yeah, Steve's right. I get 3.67 or 3.6 repeating or 3.7 meters per second squared. I'll take any of those answers. Now, really, none of those are particularly challenging, right? I would expect grade 11 physics students to be able to power through those, no problem. Okay, now, the handout that you have has on the back has some questions for you to try. You will notice that on the back there are answers along with a funny looking square thing. Does anyone know what the funny looking square thing is called?
No.
It's a QR code. It's like a two-dimensional barcode. If you scan it with a smartphone, I realize you don't all have them. I understand that. If you happen to have one and you scan it, it will go immediately to the detailed solutions on how to do it. Okay? If you don't have a smartphone, and as I said, there's absolutely nothing wrong with that, the solutions will also live here in the red binder, and they'll also be posted to Schoology as well. So there will never, ever, ever be an excuse, I don't know how to do that, because you will have the detailed solution. What you really are saying is, I don't understand how this solution works. But if you haven't looked at the solution, I can't help you. You need to take some responsibility and try it. Now, many of you have already pulled out your phones and are trying it right now. Good for you. It worked for you, Riley? Was it cool?
Yeah.
Thank you. Thank you very much. You might need to download an app, yes. Okay, so what should you do the rest of this period? You've got about 20 minutes. I would say you should either work on word problems, or you can work on the VT graphs from earlier. Okay? Reminder that there's other labs, other things you need to clean up. Okay? I will leave you a list tomorrow of those. We'll give you a little bit of time to work. All right, go for it.